It's going now.
Perfect, thanks. So, hello everybody, and welcome to the third talk of the Unlocking the Digital Humanities series. And today will be the last of the three introductory talks. From the next 8 talks will all be specialist expert talks on more individual topics and individual themes. However, there are 2 interesting talks coming up. One this week on Thursday, where Chris Blackville and Marie-Claire will talk about meaningful undergraduate research. And there is the talk next Monday, I think, at noon, where we talk about, where I will talk about language teaching and learning and how you can use tools in order to support this further. Today we actually want to talk about combining qualitative and quantitative research methods, and when I say we, I actually mean myself, obviously, and my wife, Dr. Melinda Johnston, who happens to be an art historian and who was the research cartoon specialist at the National Library of New Zealand for political cartoons. And so it's always great to give a talk together as a couple. Actually, our first fight in our relationship was about the definition of satire. So if we fight too much, just interrupt us. In any case, today we're talking about qualitative and quantitative research methods. And it's a bit, if you have followed the discussion a little bit in digital humanities about distant reading methods and close reading methods, then this is pretty much the direction that it takes. And we have some observation about typical DH projects so far, and that's where you start.
So today, really, what we're doing is giving an accessible account of a digital humanities research project. So this virus has been a project that's been quite a long time coming, and it's grown into kind of an unwieldy monster, really. But it's interesting, I think, because so far we have 3 very distinct research outputs. The first of those is we have the original commissioned chapter that we were asked to write for Canterbury University Press, which relates to a book on material responses to the Christchurch earthquake. We have our work that's ongoing with the National Library of New Zealand and the wider implications this has for metadata delivery. And we've written these up for a chapter that's going in the British Library's journal Alexandria. We also have the development of the topic modelling process itself, which Thomas has gone on to apply to several other languages, and he'll be talking about more at the Digital Humanities Conference in Krakow in July. So from these one set of questions, we've generated research outputs in art history, in library and information science, and in the digital humanities. Plus there are also the digital philology questions, which are still being researched there. Okay, so we want to begin today by setting out what we see as some common approaches to digital humanities research. And I should be clear that this is just our view, and it might be a little bit cynical, so I'm sorry for that if it is. But firstly, we have here what we're calling result-driven research. And this is the kind of model that tends to be guided by a researcher's question. So for instance, you might have a historian asking about particular published views on a particular event. It tends to have this initial information gathering and reading aspect to it, which we put here. Blue is the humanities research, green is the computer science research. So it's this first period. And at the end of that, you get kind of this hypothesis, having done that reading as the humanities researcher. And basically what tends to happen is that then gets submitted to a computer scientist, asking them to either prove or disprove that idea. And you know, I think to be fair, in some cases this kind of research does work, but the clear disadvantage as we see it is that the researcher is significantly less open to some of the things that computer science might throw up along the way.
And the other approach would be what we identify as a tool-driven research, and this actually happens a lot. There's a lot of people, also humanities scholars and all kinds of people become a lot more savvy when it comes down to computational languages. And there's a lot of playing around going on. And I mean, often it's even called a sandbox environment or something like this. And in digital humanities, you have a lot of visualization, you have a lot of data that is created, you have tools that are being created for the tool's sake. And so we have all this development work that goes into a tool where you're actually not really sure that answer research questions or not. And then you have humanities researchers who find those tools very interesting and said, I think I can answer this question with this tool. And then they take this tool and then they do their research using the tools already developed and they find a result. It should be said that, of course, this can also be successful research, but there's a lot of development work in here that will never be never go into a mature research project. And there's also the problem that we discussed last week already with the bias, the algorithm bias and the visualization bias. The researcher who's just using a ready-to-go tool is not always aware about all the bias that has been created while developing those tools. So both of the approaches might be successful, but ideally they are combined. And this is what we define as a question-driven research, where you actually have humanities research and computer science research intertwined, and they're like a dance almost. They're dancing around each other, and they're communicating lots and lots of communications. Ideally, you have a humanities research question, and you have a computer science research question, and in the development together, you actually gather your results in the end. And this is what happened with Melinda's and my use case, where I came from the topic modeling perspective, wanted to apply to the, cultural heritage data, and Melinda had her own set of questions that she wanted to have answered, and this worked quite well. In a way that we not only have our questions answered or more towards answering, but we also created a lot more side products on the way that are important for library and information science. So if you, in a digital humanities project, can get something like this, then you have a very successful project. The title of the talk was Combining Qualitative and Quantitative Methods. And it's maybe slightly different than what a sociologist would understand about qualitative and quantitative methods. The way if a sociologist talks about this, they often try to find a way how to survey the data if they use qualitative or quantitative answers pretty much from their research subjects. But here we actually we already have the data gathered, we just request the data, and then we use distant reading or close reading methods on this. And this can be very, very helpful because it addresses some sort of sampling bias. As a traditional humanities researchers, you always have to make decisions. You won't be able to research all of the data. What we had in our topic modeling process was over 100,000 abstracts, all roughly around 200 words. And if you read all of them and then try to classify them, well, that's a 3 months full-time job. So it's still possible to do that, but then if you have more and more data, you have a million texts, million abstracts, and so on, you have to make a selection what you can actually do in close reading. And the problem is it can be disbalanced if sometimes the sampling bias you're not disclosing. Most of the sampling bias is never disclosed. So if you use quantitative methods in order to get your sample, you can actually have reproducible results, and you can actually say we took those results and looked at them further because this is what was the result of our quantitative research analysis. And then in quantitative distant reading methods, we actually look at 100% of the data. So there's no sampling happening. There's no sampling bias in that research. But of course, there are still we can't exclude all the biases that are in the research project.
So this method, I think, also addresses, to a certain extent, research bias, because you can, I think, as much as this is ever possible, separate your subjective self from the research that you're doing. And for this particular project, for us, this was an incredibly important thing to do, because, you know, I was deeply involved in this topic of the Christchurch earthquake. It was a traumatic experience that I'd lived through. So for me, it was a very personal story. but I didn't want that to, to influence the research that we were going to be doing.
We haven't really said what the use case is yet, so can you quickly say something about, we haven't said that we're researching Christchurch earthquake.
Oh, well, this is what I'm about to do. Okay, so to give you some background, so the topic that we're researching here is the Christchurch and Canterbury earthquakes. To give you some background, because I expect that you know pretty much nothing about these. In September 2010, Christchurch, which is a city in New Zealand, which is not part of Australia, was hit by a massive earthquake. We were then hit on 22nd of February by another one, technically an aftershock, that was a 6.3. The earlier one was a 7.3. That shot there shows the dust cloud that was generated over the city at the time of the earthquakes when all the buildings fell down. That was one of two catastrophic building collapses that we had. This is what our roads kind of look like now. That's just to give you some background. And if you're thinking, well, a 6.3 doesn't sound all that high, I want to say that it was right underneath our city, and it was incredibly shallow. So peak ground acceleration was 2.2 Gs, and until the Japan earthquake happened a few weeks later, that was the highest ever recorded. Also, just to put that in context for you, so we're up here. You can see that figure there. The depth is incredibly, incredibly shallow. And on the scale of things, you're probably familiar with the 1994 LA earthquake. The level of up and down movement that we experienced in this quake was crazy. There were 185 deaths, and we were so incredibly lucky that that figure was so low, largely because the earthquake that happened in September meant that nearly all of the unsafe buildings were actually cordoned off as a result of that. So people tended to be gathering in what were the safer places. Now, though, pretty much half of the buildings in the CBD have been demolished. So for me personally, I was lecturing in art history and running the University of Canterbury's art gallery at the time. So on the left here is from my office, from the gallery before the earthquakes, and on the right, that is the view that we had out afterwards. You can see that that area there was cordoned off, which stopped people being, we had no deaths at the site on the day, stopped people being injured by that building coming down. So I was there, and it was horrible. But I strongly believe in the role of cartoons, that they are an important view on what was this massive event. And I wanted to write about that. But of course, as I've said, you can't go through all of that and not be biased. Cartoonists are, by their very nature, massively biased. So we wanted to use some quantitative methods as a way in, so we could start seeing some of the wider patterns in the cartoons, but without letting that bias of ours dictate the research outcomes. Okay, so what we're going to do now is talk you through our research processes step by step. As we said, this is kind of an ongoing project for us. But really this is about showing you a really easily understandable example of what's possible when you combine qualitative and quantitative research in the digital humanities.
So, and we start to talk you a little bit through it step by step. It might be a bit easy. One of the advantage that we're talking about cartoons is that we always can show you some funny pictures on the side. So, but we try to start to talk you through the whole research project from data preparation to preliminary results. Some of it might be very, very simple, but just bear with us because we see it also a little bit as an introductory class or lecture into digital humanities. So the first thing you have to do is try to access your data. That is absolutely normal. And the good thing about New Zealand is, to some extent, it's very small and very ambitious in a good way. So they try to have a central service for all their digital cultural heritage data, and you can request this using an API. The service is called Digital New Zealand, and it has a lot of collections. The national. So
all of the university libraries, their collections that have been digitized are linked through to it.
So, and that's great. So, in order to request the data from another machine, you're using an API. Not everybody in this room will be familiar with an API request, but this is roughly what an HTML API request looks like. It looks a bit blurry on the first look, and it's probably not easy to see. But it's very easy if you take it apart. So this is the API we are requesting, API Digital New Zealand. It's really free. This is the third version of this. We request records in a certain format, JSON, which is one of the two most used standard formats in the JSON or XML. We have an API key, which is nothing but a password, a user password. So here you have to put an API key. I've decided not to print it on the slide. But it's a free key and you can request it on the website. You have a search text. You have a category and a collection where you search. And you can request certain data fields as well. We requested the verbose formats just because we didn't know what fields are available. So we told the computer, give us all the fields you have. And then there's some other options. So it's actually human readable as well, but it just has to be this method. And because we had one quake, because there were more quakes, and one was named the Christchurch earthquake, and the other one was named the Canterbury earthquake, which is the same region, we actually had two API requests, and then tried to check out the double ups in a later stage. Yeah. So this is
what we get back, or rather, this is actually a screenshot of what we get back. This is the JSON file delivered. And there might be developers who disagree with that, but for me, that's absolutely horrible. Like, I do not like looking at that one bit. So to be really very, very clear about what we're talking about here, you've got two kinds of data. On the left is the catalog record, so not the item itself, but the metadata around that collection item. The catalog record that you're more used to looking at, and on the right you have that JSON output. One is designed to be read by people, one is designed to be read by a machine. And also I just want to signal here, because it will matter later in terms of what we're talking about in topic modeling, you've got here these authority headings, the subject headings, the place headings, as opposed to the scope and contents, which is a discursive description and context in relation to what that particular cartoon is about. Okay, so second step is restructuring that data. And that's about moving from the JSON source file to our desired output. And that was an incredibly involved process, and the steps get a little bit mixed up. We're going to try and keep it as clear as we can. In the end, we went through something like 700 steps. You know, some of these are really, really tiny, but they took us from about 1,300 records down to 654. So it begins with pruning the data, what I call chucking out, basically. So we removed the double ups, as Thomas explained, because we had those two API requests for Canterbury and Christchurch. That was one of the things that had to be done. We removed photos using the photographic archive field, and we also removed DPP, which is drawings, paintings, and prints, and ephemera, because it was a really easy way to realize that we weren't looking at cartoons there, because we'd asked this API request to return all images. We also removed those outside our date range, so earlier than 2010, because of course this was not Christchurch's first earthquake, but it was the one that was really significant that we were looking at. But we also want to restructure or tidy up that data. So we want to be able to recognize those things in that stuff that matter to us and put them into nice, neat, readable columns. And I'm going to talk very briefly about two of those things and why they perhaps weren't as easy as they might have been. And this really is where library metadata delivery meets collection reuse. As I said earlier, this is an ongoing project. We're working with the National Library. It's partly written up in Alexandria. And you know, this is, as Thomas said last week, that intersection between the GLAM sector and digital humanities. Okay, so identifying the cartoonist. You'd think this would be quite easy. As it turns out, because of which we shall politely call a quirk in what the National Library does, we have the cartoonist, the title, and the date are all in one field, which is not nice for separating. But the cartoonist is actually not always in the title. So we think, okay, maybe we should search for them in the field called as cartoonist. They're not always there either. Maybe we should, they're actually hardly ever there. Maybe we look for them in the field as creator. They're not there. Where we found them to consistently be located was in the collection root field. This kind of thing makes it really hard as a researcher. It's kind of counterintuitive. We also had...
Yeah, sometimes when you do research with your wife, you're kind of in a difficult dating situation. But it's, so we try to extract the date from the JSON file as well. And if you can see on, maybe you can't see because you sit too far away, but we actually have 5 different fields that have something to do with date. Updated it, created it, artwork date, display date, syndication date. The funny thing is, none of these dates actually say when this cartoon was published. You would expect something as artwork date, but all the cartoons then would be published on January the 1st of that year. And the other dates are either unimportant or too imprecise. We actually have a published date, but it's just empty. So it's and this is something you have constantly in your data. When you actually want to look and try to find the date, you find it here. Again in the title field, 25th of February 2011, successful dating. Yeah. The problem is this is within a text, so and sometimes it's a bit messy, sometimes it's in a different situation, but luckily it's regular enough for a machine to extract it. We always have 1 or 2 numbers, we always have some part of string, and then we always have 4 numbers. And you can actually use a quite simple regular expression to actually grab this string out of every title field in the collection, and you can create a new date. And when you did all of this with just a little bit of regular expression and just a bit of managing and the data, you actually get something nice.
So yeah, we did all this checking out, we did all this tidying up, and we ended up what I think is with this beautiful Google Fusion table. And I love this Fusion table because I can read it. I can edit it, I can navigate around it. As someone with no programming knowledge, this for me is something that I can actually work with. And we had a question last week that was addressing what kind of programs are out there for researchers who want to manage that data, but are not, super computer savvy, super computer confident. And I think we were using, in particular, Google Fusion Table and OpenRefine as well as ways that you can manage this volume of data comfortably without necessarily.
OpenRefine is pretty much like an Excel on speed. So it's it has a very, very nice faceting options, and you can use 3 different programming languages in order to manipulate the data as well. So it's so I think the most accessible data managing, data wrangling software around is Fusion and OpenRefine, both of them open source.
And we're pulling through the URLs for each of these items, so I can click through back to the collection record and actually see what the cartoon looks like for each one. Okay, so the digital methods up to this point have been really amazing at getting that data set cleaned up, but it's basically only as good as the library's catalogue records. So, to be clear, what I'm about to talk about now is not really digital humanities, and you simply wouldn't be able to do this with big data. But part of our project was kind of testing where the library is at, what they were actually doing. That was one of our research goals there. So we noticed recurring problems with the descriptions that were often throwing up false results for us. So just really quickly, one of those was irrelevant information. There was a tendency here, this chap is called Jerry Brownlee, he was the Minister for the Canterbury Earthquake Recovery. That has been written here in the scope and contents that he has that role as Minister. This cartoon referred to something really stupid he said about Finland. Absolutely nothing to do with his role in relation to the earthquake. So you've got over-description that is throwing up false results for researchers. This is one of my personal favorites, you have inaccurate description, because of course the archivists writing these records are real people and they get stuff wrong. This person here has said that a dove holds the world still between its outstretched wings. Context is a tribute to the people of Christchurch, which is great, but it's not. This is about the Southern Steel netball team playing the Queensland Firebirds. It's got nothing whatsoever to do with the Christchurch earthquake.
Netball is like basketball for English.
This is where that not only researcher bias, but the library's bias comes in as well. So these people who were describing them were seeing everything, because everyone was living and breathing earthquakes at that point in New Zealand. We also had over-description, and this was also incredibly unhelpful for me. So this was a cartoon about the economy, where someone had felt the need to talk about the impact that the Christchurch earthquakes had on the economy. So in a much wider sense, yeah, it kind of involved the earthquakes, but not really. Okay, 4th step was matching that data to our specific research needs. And this is where those digital methods, the quantitative, need to be matched with an understanding of your topic, so the qualitative. When I looked at the data, I realized that there were cartoons that were coming through that didn't really fit with what I was trying to figure out. But I'm glad they came through. You know, they might not suit for this particular research topic, but they should be there, available for someone else's different research view. So I got rid of earthquake metaphors. So there were heaps of these. We had a process of red stickering of buildings, declaring them unsafe. So there were cartoons where, you know, women wanted to have their husbands red stickered. There were a lot of rugby earthquake metaphors. So this one here. The problem with this particular one is that it was tagged as being about earthquakes Canterbury region, which is not helpful because it's not. It's using the fact that the earthquakes then move into becoming a trope as far as cartoons are concerned. We also had non-editorial cartoons that were coming through. That was a researcher decision that I made, that these are cartoons that appear other than on the editorial page of a newspaper. And in New Zealand in particular, they are subject to different legal actual requirements. You have more freedom on the editorial page than you do on other pages of the newspaper. And we had the need to check for whether it was actually published or not. This is a strength and a weakness of the National Library's cartoon collection in New Zealand. We had these two cartoons which are showing with very, very similar dates. The one on the right was submitted to the journal that it was to be published in, but the editors decided there not to run it. Instead, the one on the left ran. So we had this in the collection, but actually if you go back and check it against the published record, this never went out into the public. And these are, it's a pain because you can't take it for granted that what's there was what was in the papers, but it also gives you research gold because this tells you what editors didn't deem appropriate in any particular context to run. Okay, so I added nearly 100 cartoons that I found that we didn't have in the collection, and I also removed nearly 200. So at the end of doing that, we had this really, really beautiful data. So we wanted to start doing some basic things with it. And the key point here is that these are all scalable. We were dealing with a few hundred cartoons, but we could equally be dealing with a few thousand at this point.
So I'm very pleased, by the way, that I managed to get a monkey into this presentation as well. Like last week, I tried to bring a monkey in my third presentation too. Anyway, so quantitative analysis at any scale, that's one of the things you actually want to see. You want to have all these cartoons traceable over time. You want to know when which publisher published how many cartoons, what the different trends are, and so on. And because we have everything combined with the topic modeling score and the date, and we have everything extracted, that's easy. And we can create these visualization like this, where we can actually sort according to newspaper stuff, and which newspaper, which publishers did what at which time. And when we actually look closer to the different publishers, and we can first of all count the cartoons that have been published in the different newspaper outlets, the Dominion Post or the Thousand and Time, and so on. And we can even colorize what is their earthquake-ness, earthquake-relatedness to it. So we not only count them, but the bluer the dots are, the more they actually have to do with earthquake as well. So all those cartoons counted have something to do with earthquake, and the blue ones have particularly something to do with this. And we can compare the numbers. And yeah, in a nutshell, which is not surprising, the more north you go from Christchurch, the less people will publish about this earthquake because they're just busy with other stuff, unless the cartoonist of that newspaper has a special personal connection to Christchurch. Then you, of course, get this as well. And being able to find the exact date is very important.
And it's simply because of the way the National Library's catalogue was structured, as we explained, you can't surface that as a traditional researcher. You need to use those digital humanities methods. And the date is so incredibly important. You know, we're not talking about an artwork here where you can date it to the year or something like that. The actual day that this cartoon ran matters because they are such a quick turnaround response to events. It also matters because aftershocks are not actually counted as individual events. It's not like talking about, you know, the event of the First World War or whatever. It's they don't have Library of Congress subject headings, which makes it massively problematic. The only way that I can actually identify that this was a cartoon about, say, the June aftershock or the Christmas aftershock that we experienced, that is by using that date function. So again, basically the digital humanities methods allowing us to do more than we could do with those traditional catalogue records. But we want to do more than just basic things. We actually want to put that data to work, and you know, we really want to use it. So this next slide here, this represents us. And I was on the side of authority headings. So that is categories applied by an archivist using Library of Congress. So they're applied to things like names, places, subjects. And Thomas was on the side of topic modeling. He wanted to use that scope and contents field.
Yeah, so just a quick introduction. Not everybody might be familiar with authority headings. The Library of Congress, that we actually saw last week, that was exciting, came out with a list of headings that can be tagged, list of tags that can be tagged by librarians to describe certain things that are in this archival item. And it's always applied by a person, and the person analyzes and then tags the image. So a lot of the decisions the person is making to actually apply a certain tag is not recorded at all. So there's no bias recorded. If two different archivists are actually doing that, that means they not always make the same decision. Is it snow or is it snow in Canterbury? There are different tags. And the other thing is that the same person on a Monday might make a different decision than on a Thursday, and none of the bias that is in this decision is recorded. In the scope and content, we have a very wordy description of what's going on in this cartoon, in this archival item. And I'm not saying it's not biased, it's heavily biased. But the good thing is all the bias is recorded because it's fluent text. It's not just one decision, but it's a lot more words that where we can clearly see the bias. It's topic modeling uses those scope and content fields in order to apply an algorithm over this. And it analyzes the description, and then it finds statistically significant recurring pattern of co-occurring words, and then calls this topics, those tiny word clouds. And it runs a couple of times. So it evaluates the best distribution, and then it runs again. So normally you have to run it 500 to 5,000 times over a certain data set to get reliable results. But this is still fairly speedy.
I should also just say before you launch into that, something about what the National Library does is they get these cartoons in and they describe them very, very quickly. And they